Hello and welcome to this webinar brought to you by Kentucky Commercialization Ventures, KCV, an initiative of Kentucky Science and Technology Corporation. This webinar will cover the technology commercialization process. Specifically, we will dive into some tools that help innovators, such as yourself, navigate it. These include the time-to-market process, TTM, and the market attack plan, MAP. To start, we will follow this agenda. We will get a brief overview of the time-to-market process. We will also dive into the key phases of the technology commercialization process and some of the many programs, tools, and solutions that are out there to help your idea succeed. The time-to-market (TTM) process is an empowering framework of action that brings together industry best practices while encouraging innovation and entrepreneurship in a variety of value-added business models. The focus of this introductory webinar is on the execution for the overall commercialization process and the best practices for a key phase of the TTM, the market attack plan, the front end of the process. Tools and frameworks associated with a MAP, technology commercialization plan, technology commercialization ecosystem, will be presented along with practical case studies. This is the pipeline through which your idea should develop. This will serve as our visual aid as we walk through the technology commercialization process. Within this pipeline are several phases. Within each are milestones or projects your idea should be undertaking to progress further into the pipeline. We will explore each of these more closely throughout the video. Phase 0 is the first major step in your journey through the pipeline. In Phase 0, you will learn how to write an idea disclosure, how to engage with KCV, and some IP 101. The KCV Fellowship Program is one of such engagements with KCV following submitting your idea disclosure. It is a hands-on experiential learning program where you receive proven frameworks, resources, and networking opportunities. Another step in phases 0 and 1, often after the fellowship program, is the regional I-Corps program. I-Corps is an immersive entrepreneurial training program that helps prepare innovators to extend their focus beyond a laboratory. Following that, there is the opportunity for even more training and funding through a national I-Corps program. In terms of MAP, we will explore some of the ecosystem mapping process, as well as other factors that help bring a map together. When it comes to the fellowship program, don't just take our word. Here is what some of our great fellows of previous cohorts thought. Now shifting our focus more towards MAP. Ecosystem mapping in technology commercialization involves data gathering, market research, networking, and collaboration with various stakeholders. By understanding the ecosystem and the relationships among different players, developers can identify potential partners or collaborators to enhance the technology's capabilities and market reach, identify potential barriers and challenges to adoption and address them proactively, develop targeted marketing and sales strategies tailored to the needs of specific customer segments, position the technology effectively by highlighting its unique selling points compared to competitors, and attract investors and funding by showcasing the technology's potential impact in the market. A commercialization ecosystem mapping system is a visual representation of the time-to-market (TTM) process, flow, interactions, and relationships of all value chain partners, developers, customers, marketing, manufacturers, etc. Ecosystem maps are tools that designers create to understand the relationships and dependencies between the various value chain partners that contribute to creating customer experiences. The result is delivering the best customer experiences, ensuring customer loyalty. In the context of technology commercialization, ecosystem mapping refers to the process of identifying and analyzing the key stakeholders, resources, and interactions within the broader ecosystem that can influence the successful adoption and commercialization of a new technology or innovation. Ecosystem mapping is also vital for obtaining government funding and sponsored research. Ecosystem mapping plays a critical role in guiding the strategic decisions and actions needed for successful technology commercialization, ensuring that the new technology aligns with market demands and has the necessary support to thrive and make a positive impact. TTM ensures end-to-end alignment. Some entities to consider. 1. Market engagement. Identify potential customers, end users, and target industries that could benefit from the commercialization of your idea. This involves understanding their needs, preferences, and pain points related to its application. iCorp is a good process for this. 2. Competitors. Analyze existing technologies or solutions that compete with your newly developed idea. Understanding the competitive landscape helps in positioning it more effectively. 3. Regulatory environment. Understand the relevant laws, regulations, and standards that could impact your idea's adoption and its compliance requirements. 4. Suppliers and partners. Identify potential suppliers of raw materials or components required for manufacturing the product. Additionally, look for strategic partners who can help enhance the product's value proposition or distribution channels. 5. Investors and funding sources. Identify potential investors or funding opportunities that can support your idea's commercialization process. 6. Support infrastructure. Recognize the necessary infrastructure, such as research institutions, incubators, accelerators, and industry associations that can provide support, resources, and networking opportunities. 7. End users and feedback. Engage with potential end users and gather feedback during the technology development process to ensure the product meets their needs effectively. A technology readiness assessment is a good tool for this. It should be noted that items 1 through 7 fall under the Market Attack Plan, which is a key output of the TTM front end. The big takeaway? Ecosystem mapping guides strategic decisions for successful technology commercialization, aligning new technologies with market demands and ensuring end-to-end support for impact. Now that we have quickly breezed through phases 0 and 1, we are on to phase 2. Phase 2 of the pipeline deals heavily with the readiness level of your idea. Technology readiness levels are, as the name implies, levels. We will explore technology readiness and the various level milestones you should hit as you progress through the pipeline. We will also discuss partnerships in this phase and their purposes of furthering your idea's development and/or its funding. For your idea, most likely you are the engineer or you are working closely with one. A major role for an engineer in the idea development process is dealing with failure modes. Failure modes, FMs, can be defined as ways in which a machine, equipment, or product can fail. Some examples include failure to operate at the prescribed time, failure to cease operation at the prescribed time, or failure during operation. FMs are customer dissatisfiers, identified through the voice of customers and defined in MAP. FMs are controlled via the TR process and methods such as FMEA and Lean Six Sigma. Failure Mode and Effects Analysis, FMEA, is a step-by-step process that helps identify potential failure points in a product, service, design, or manufacturing process. Technology readiness is a state of understanding with supporting data from which a product can be designed and implemented on a predictable schedule, such that the product will perform in a predictable manner, absence of failure modes, in the presence of predefined input parameters, their variabilities, and in the presence of known noises. Your idea should follow a similar schedule in regard to readiness as the one pictured here. Design robustness, which is the minimization of variation in a product and its performance, is often measured by FMs or the absence thereof. As you can see in the figure, FMs are projected, identified, and controlled in that order as your technology readiness level continues to rise and improve. Now we are almost there. We have explored some key assessments and tools to aid you ever further into the commercialization process, but now we look towards Phase 3. Phase 3 will see us drive ever closer to the licensing spin-out point. In this phase, you should expect to see your go-to-market plan, your technology commercialization plan, design rules, and other specifics fleshed out. The Market Attack Plan contains the business plan, the TCP, and the ecosystem mapping, commercialization partnership model. A technology commercialization plan, TCP, outlines the strategies and steps to bring a new technology or innovation from the research and development stage to the market. It involves the process of transforming a concept or idea into a profitable product or service. The technology commercialization plan provides a roadmap for turning innovation into a successful business venture, and it should be adaptable to changing market conditions and new insights as the process unfolds. Here's the technology commercialization plan checklist. This is a wonderful guide to checking off your boxes as you progress toward your commercialization goal. Market research. outlining IP protection, analyzing risks, financial projections, regulatory considerations, partnerships, etc. Many of these topics you have approached or answered in prior phases. However, this checklist helps to ensure that your idea is prepared and ready to adapt as it pertains to entering the future market. Now let's discuss some staging and positioning for tech transfer. Most technologies need further advanced development. This can be for proof of concept, design for manufacturing, design for service, etc. Funding is a key. Inventors would like funding to continue developing their idea. Tech transfer often recommends funding for specific product applications and utilizing a co-development model with industry partners. Meanwhile, inventors should define design rules, expand on technology operation description. Maybe co-development is your thing. Then you need a plan with your industry partners. This plan should include define and assess manufacturing readiness, develop technology commercialization plan, TCP, define co-development model, extending the R&D enterprise, define go-to-market requirements. As an innovator, one of your many roles includes defining the design rules of your idea. In engineering, design rules refer to specific guidelines and principles that engineers follow during the design process to ensure the functionality, safety, and reliability of a product, system, or structure. These rules are established based on industry standards, regulations, and best practices. The application of engineering design rules helps engineers make informed decisions and produce designs that meet certain criteria. The specific engineering design rules can vary depending on the engineering application. Adhering to these rules helps engineers produce designs that are not only functional, but also safe, reliable, and compliant with applicable standards and regulations. These rules are an outcome of technology readiness, and they enable transfer to design and manufacturing. On this slide are a few examples of the many design rules that you might find could be associated with your idea, and thus should be under your consideration. These range anywhere from materials and manufacturing processes to mechanical or electrical design to software considerations. Building off design rules and circling back to our mention of co-development with industry partners leads us here to manufacturing readiness. Manufacturing readiness refers to the state of preparedness and capability of a product or technology to be successfully produced, assembled, and delivered at the required scale and quality in a manufacturing environment. It is a critical aspect of the product development process and ensures that a product is ready to transition from the design and prototyping phases to full-scale production and commercialization. A manufacturing readiness assessment will assist you in determining where exactly your idea stands on this preparedness. Aspects considered in this assessment include the maturity of your design, the manufacturing processes, machinery, tools, etc. that will be required for production, the supply chain you intend to use and sourcing for necessary raw materials or parts, establishment of quality control and testing standards. Building further on the co-development model, you also want to focus on quality. Per Juron, quality can be described as fitness for use. According to Crosby, it is conformance to certain specifications. All in all, it is the capacity of a product or service to meet or surpass customer expectations. Some dimensions of quality include performance, reliability, durability, and aesthetics. As we begin to close out, I want to re-emphasize the TCP checklist. Again, many of these topics listed here you will encounter and develop solutions for as you progress through the pipeline. And if you do encounter a topic you haven't developed a solution to, then don't worry. That's what this checklist is for, to serve as one more check before you enter the licensing spin-out point. Here is a final look at the technology development pipeline. No matter where you are with your idea, whether that be conceptual or with a prototype in hand, we hope this webinar gave you some insight into the great process that is technology commercialization and the many ways you can interact with KCV and how we may assist you in your commercialization journey. Thank you for tuning in to this webinar, and be sure to check out our future ones.